Now, we will move on to bending moment. So, bending moment, as the word moment indicates, moment is nothing but the force multiplied by distance. So, in case of point load, if I am interested in calculating bending moment, in case of point load, force multiplied by distance between the load about which bending moment is taken, that is distance between the point about which bending moment is taken and the line of action of the load. Say you want bending moment at one point and your load acts at 2 meters from your point. So, the bending moment produced by the load will be that load multiplied by this 2 meters will give you the moment created by or moment created by the load, applied load. So, it should be seen whether the load produces clockwise or anti-clockwise moment in this case. In case of shear force, we deal only with the force, that is why we are bothered with either it acts upward or downward. But here when moment comes into play or action or we are concerned with moment, then we should see whether it produces clockwise or anti-clockwise moment. For example, if your load is here, say 10 kilonewton of load acts here and this distance is 3 meters and I am interested in bending moment at this point A. So, as I defined, moment is force multiplied by distance and we should be very clear that you should know what is the distance. You should not simply take the distance or blindly take the distance, any distance. The distance we should be very clearly focused that you should find the distance between the line of action of the load. So, here we have the line of action of the load is this and then the point considered is A. So, the distance between the point about which moment is required and the line of action of the load, this distance we are interested in finding the moment produced by this particular 10 kilonewton load. So, the moment produced by the 10 kilonewton load about point A will be this 10 kilonewton multiplied by 3. So, 10 into 3, so which 30 kilonewton meter. So, 10 kilonewton, so kilonewton unit and then it acts over length of 3 meters. So, kilonewton meter, and we should also see what is the moment produced by the load. So, here this load will act like this. So, if you connect the arrows, then we can see what is the nature of moment produced by this load. Say if I connect by means of arrows like this, say it is very clear that the load produces a clockwise moment about this point A. And contrary to this, say if you have a load here, and I am interested in bending moment at point B, say let this distance be, this distance be 2 meters and if this load is 15 kilonewton. So, moment produced by this 15 kilonewton load will be 15 multiplied by 2. So, we are very clear force is 15 and the distance is 2 meters. So, the line of action of the force is here and the point about which moment is required is here. So, the distance is 2 meters. So, moment will be 15 into 2 and the nature of moment produced by this load will be, say it will produce, if you connect like this you will have various arrows. So, if you see the arrow, then that will themselves indicate what is the nature of the moment. So, can you say what is or can you feel how what is the moment produced by this load? So, this will produce an anti-clockwise. So, we can clearly understand, say if you have several loads, you should be now in a position to calculate the moment produced by various loads about any required point. Say we may be interested about this point or we may be interested in moment about this point or any point. So, you should be clear that if I want moment about any point, I should know what are the forces acting and then what is the distance between the line of action of individual force and the point and nature. For example, say let this point be C and this load is 5 kilonewton, this load is 10 kilonewton and this is 15 kilonewton. Say let this distance be 1 meter and this distance be 2 meters, this distance be 3 meters. So, you will calculate carefully the moment produced by each of the loads about this point C. So, we have 5 kilonewton load acting at a distance of 1 meter from C. Therefore, this will produce an anti-clockwise moment of 5 into 1. So, 5 kilonewton meter. This is the moment produced by this particular load and if I take this load, load multiplied by the distance is 2 meters, and the nature of moment produced by this load will be 10 into 2, the nature will be clockwise, while this load produces anti-clockwise moment, this load will produce a clockwise moment, and the moment produced by this 15 kilonewton load will be 15 multiplied by, say we have here 3 meters and we have 2 meters up to C. So, totally we have 5 meters from C, the 15 kilonewton load acts at 5 meters from C. So, the moment produced is 15 into 5. So, 75 kilonewton meter, and the nature of moment will be. So, simply connect this load and the point and see, and connect by means of small arrows, that will help you to decide the nature of the moment. So, now we are clear what is the shear force, what is bending moment. So, we should be very clear that what is the distance between the force and the point considered, and the sign convention for bending moment will be LC, LAC, RC, RAC. So, LC means left clockwise, LAC means left anti-clockwise, and RC means right clockwise, and RAC means right anti-clockwise. Be clear with the sign convention before proceeding to the calculation of shear force and bending moment in beams. The sign convention we can remember like this. So, in case of shear force, what is the sign convention, and in case of bending moment, what is the sign convention. As I said, in case of shear force, we should see whether it acts upward or downward, left up, left down, right up, right down, and bending moment sign convention we should see whether the moment produces clockwise or anti-clockwise, LC, LAC, RC, RAC, and the sign will be plus, minus, minus, plus. So, this is the universal sign convention, or if you remember like this, we will not forget the sign convention. So, sign convention I repeat, left up, left down, right up, right down in case of shear force, and in case of bending moment, left clockwise, left anti-clockwise, right clockwise, right anti-clockwise with a convention plus, minus, minus, plus. In case of UDL, so as I said, we will also have a uniformly distributed load. If it is a point load, we will be very clear that it will have a line of action, and you will have the point about which moment is required. So, the distance between the line of action and the point we can easily take, but in case of uniformly distributed load, it will be distributed over length, it will be distributed over length. So, we should see what is the total load first, and then distance where the load is concentrated. Say for example, if I have a uniformly distributed like this, say if a simply supported beam subjected to say some 30 kilonewton per meter, and this is A and this is B, or you take a cantilever beam. So, to explain easier, we will take cantilever beam, say this is A and this is B, and we have 10 kilonewton per meter load acting, and I am interested in bending moment at this particular point C, and this distance is 3 meters. So, I want bending moment at C. So, we should first find what is the total load available in the portion BC, because we are interested in finding bending moment about C, and we have up to B. So, up to BC, what is the total load? So, the load acts here is 10 kilonewton per meter, and it acts over a length of 3 meters. So, 10 into 3, 30 is the total load acting beyond C up to B, and this load, this particular load UDL will be concentrated at its center of gravity. Say if you have a particular length of UDL, the resultant will be passing like this, resultant of this load, or the UDL will be concentrated at the center. So, here the load will be concentrated here at 1.5 meters. So, now we have the load concentrated here, and you have this 1.5 meter. Therefore, 10 into 3 is the load, and distance is 1.5. So, 30 into 1.5, 45 kilonewton meter will be the moment produced by the UDL up to point C. In case of point load, we have point load multiplied by distance, and in case of uniformly distributed load, you need the total load first and then the distance. So, to calculate total load itself, we have this intensity of UDL, that what is mentioned in this slide. Say intensity of UDL into length over which it acts. So, that will give you the load and multiplied by distance between the CG of load, that is center of gravity of the load and the point considered. This is to be remembered while calculating moment in case of UDL, uniformly distributed load.